Hello, this is Mr. Carlin. Let's talk about lesson 10-5, mean absolute deviation. Our I can statement says, I can understand how the mean absolute deviation describes the variation in the data set and interpret its value within the context of a given real-world scenario. Okay, so our vocab is going to be mean absolute deviation that we're going to learn. You have to learn how the range and interquartile range describes the spread of the data set. Another measure of variation is the mean absolute deviation, or MAD. Okay, we like to say it's MAD. MAD of the data set is the average distance between each data value and the mean. Okay. So what we do when we're finding the MAD, or the mean absolute deviation, is we first find the mean of a data set. Remember, to find the mean, you add all the numbers together, then you divide by how many numbers there are to get the average. Once you have that average, you're going to find the distance of every data point from that average. Okay? Then you're going to find their average on those distances. Okay? It's the average of the distance. So in this data set, we have an average of 52. Okay, so in a number line, average of 52. And then 46 has a distance of 6. I like to write it under there too. Okay. 58, okay, 58, which is out here, okay, or here it is down here. Let's see if I can zoom this out just a little bit. Okay. 58 has a distance of 6 also. 50 is 2 from 52, 2 from the median, or the mean. And then 53 is 1. 48 is 4. And then 57 is 5. Once we have those, we're going to average those distances. Okay, so we found the distance of each one, and then we're going to find their average. Okay, turn the page. So we had all of those averages listed. We're going to find their average. So we ended up with 6, 4, 2, 1, 5, and 6 divided by 6, and we end up with 4. So the mean absolute deviation of that data set is 4. And in other words, the average distance each score is from the mean score is 52 is 4 points. Okay. Now, what does that mean if we have a smaller mean, or a smaller MAD versus a larger MAD? Well, if we have a larger MAD, that means the variation is more spread out, or the data is more spread out. If we have a smaller MAD, then that means that your data is more bunched together. Okay. Alright, so let's do this first example together. This table shows the maximum speeds of 8 roller coasters. We need to find the mean absolute deviation of the data set. And we're going to explain what the mean absolute deviation represents. So first we're going to find the mean absolute. First, to find the mean absolute deviation, we have to find the mean. So we're going to add all of these together and divide by 8. Okay, so when I do that, I'm going to get my calculator. 58 plus 88 plus 40 plus 60 plus 72 plus 66 plus 80 plus 48. We end up with 512. We're going to divide that by 8. Okay, and that means we have a mean of 64. The next thing is to find how far apart each one of those are from the mean. So each data point has a distance from 64. So how far is 58 from 64? Okay, so let's find 58 here. 58 is here. Okay, and it has a distance of 6. 88 has a distance of 24. Okay, we find all their distances. So then 40 has a distance of 24. 60 has a distance of 4. 72 has a distance of 8. 66, where is 66? Right here, has a distance of 2. 80 has a distance of 16, and 48 has a distance of 16. So we're going to add all those together and then divide by 8. So we end up with 100 divided by 8. When we do that, we end up with 12.5. So our mean absolute deviation is 12.5 miles per hour. And to explain this, okay, we say that the average distance each roller coaster speed is roller coaster speed is from the mean is 12.5. And we would say that that data is more spread out because it is a larger mat. So there's more variation in the data. Okay. I want you to pause the video, do this check question. Okay, you don't necessarily have to create a number line. After you find your mean, you can write underneath each one of these what the distance of each number is, okay, to help you out. So pause the video, do that. Okay, now let's check your work. It says the table shows the number of daily visitors to a website on the internet. We need to find the mean absolute deviation of the data set. We're going to explain what the mean absolute deviation represents. Okay. So first, we're going to find the mean, okay? So to find the mean, we're going to do 112 plus 145 plus 108 plus 160 plus 122. So we get our calculator, add all those together. 112 plus 145 plus 108 plus 160 plus 122, and that is going to come out to be, I'm out of space, so let's do it over here, 647. And then I had 1, 2, 3, 4, 5 data points, so I divide that by 5. So my mean is 129 4/10. Okay, so it wants us to round to the nearest hundredth whenever we go to find the mean absolute deviation. So now we need to find out the distance that each one of these numbers is from that. Okay, so what we're going to do is we're going to take 129.4 minus 112, and we get 17.4 for the distance there. Then 145 minus 129.4. So this one is 15.6. And this one, 129.4 minus 108. So that has a distance of 21.4. This one is 160 minus 129.4. So this one's 30.6. This one, 129.4 minus, how do I clear it? Minus 122. So this one is 7.4. Now we're going to add all those together and divide by 5. So 17.4 plus 15.6 plus 21.4 plus 30.6 plus 7.4, and then divide that by 5. So we get a MAD of 18.48. So the average speed, right? Is that what it is? The average distance each row. So when we explain this, we say that the average number of daily visitors, there we go. Average number of daily visitors from the mean is 18.48. Okay, and that data is more spread out. Okay, or I would say there's more variation of that data because there is a higher number. Okay, it's definitely double-digit higher number. All right, let's look at this data set. In this example, it says 2 driving schools use the same practice driver's test out of 100. School A had scores of 70, 79, 80, 82, and 95. School B had scores of 77, 83, 83, 81, and 82. It wants us to find the means and the mean absolute deviations of each one. Okay, so we need to find the school A. So school A is this. So we're going to add those together and divide by 1, 2, 3, 4. Okay, so we're going to do 70 plus 79 plus 80 plus 82. Oh, and that 95 plus 95. So 70 plus 79 plus 80 plus 82 plus 95 equals 406, but we divide that by 1, 2, 3, 4, 5 data points. So we have a mean of 81 2/10. Okay, that's the average. So then we need to figure out how far away is each one. Okay, so for 70, we're going to do 81.2 minus 70. So it has a distance of 11.2. Then 79. So then we're going to do 81.2 minus 79. So that one is 2.2 plus 80. Well, that one's going to be 1.2. And then 82. So you can do 82 minus 81.2, yeah. Okay, and then so that's 0.8. And then 95 minus 81.2. So that's 13.8. We're going to add all that together and divide by 1, 2, 3, 4, 5. Okay, so 13. Actually, let's start at the beginning. 11.2 plus 2.2 plus 1.2 plus 0.8 plus 13.8 divided by 5. So they have a mean absolute deviation of 5.84. Okay. Whew, a lot of work, I know. Just a lot of adding and dividing. That's all it is. All right. Now we got to do this one for school B. We're going to use these numbers. Okay. And really what you could do, instead of doing them this way, you could stand them up. Sometimes that helps. Okay. We have 77, 83, 83, 81, and 82. Right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so find their mean. We're going to add those together. Plus 83, plus 83, plus 81, plus 82. So again, is that 406 again? We add all that together and then divide by 5. So they have the same mean, but will they have the same MAD? Well, let's find the distance. Okay, so we're going to find the distance of each one of these. I'm going to use my calculator. Okay, so 81.2 minus 77. So this one is 4.2. Okay, and we got 83 minus 81.2. So that's 1.8. This one is is also going to be 1.8, same number. This one is 0.2, and then this one should be 0.8. Okay. No, not 0.8. Tried to do that in my head for some reason, and it's been a long day already, so let's just use a calculator to make sure we're right. Yeah, it was 0.8, Mr. Carlin. Okay, so now we add these together and find their average. So 4.2 plus 1.8 plus 1.8 plus 2 plus 8 is 8.8, and we're going to divide that by 5. So they definitely have a lower mean absolute deviation. So the mean absolute deviation of school A is greater than school B. Notice the difference in those two. Even though they had the same average, one still had less variation. So school A, the data score or the scores are closer together. Okay, they're closer to the mean than school B, which is more spread out, not clustered. Okay. I want you to go ahead and do practice problems on page 170 or 573, 1 through 5. If you got any questions, be sure to ask your teacher. Make sure you check your work with your teacher. Thanks.